Hey guys, this is example 2 in 4.5. The linear approximation 1 plus x to the k power is approximately 1 plus k times x. To find an approximation for the function f of x for values of x close to 0, near 0, okay? So as you can see, this is the linear approximation here, linear equation, okay? This is actually a power function. Can you see it? Power function. Now, it can also be a root function if I were to raise it to a power of a half or a third or a fourth, right? So this is a formula to find the approximation for roots or power functions when x is close to 0. Okay? So let's find the linear approximation of equation f of x equals 1 minus x to the 6th power. So by definition, it should be the same thing as 1 plus x to the k equals, or approximately, 1 plus kx. So what you really want to do is what is k and what is x? K is the power. So in this case, k is 6, okay? Your equation is 1 plus x. So x is really technically negative x in this case. So when I find the linear approximation, is 1 plus k is 6, x is negative 6. X is negative x, okay? So this equation comes out to be 1 minus 6x, and that is the linear approximation of this power function. And that's all you're supposed to do. Easy peasy. 2, before I go and plug it into the equation of approximation, I would like to rewrite this as a power function. In this case, your power is negative 1. So k is negative 1. And similarly, I'm going to use this equation again. And look at the equation, okay? It's 1 plus x, but this is a negative, so be very mindful of that. So would you agree that I would have to switch that over? So your formula sets is 1 plus kx, okay? Which is, but you have a 2 in the front. So what do you do with that? You put 2 in the front, just like that. 1 says it's a 1. Oh, I'm sorry, k is a negative 1. My bad, k is negative 1. Okay. K is negative 1, so I'm going to bring down the plus sign. K is negative 1, x is negative x, okay? X is negative x, so if there's a 2, you just bring it to the front. So this linear approximation is 2, 1 plus x. Distribute your 2. So this is 2 plus 2x, and that is the linear approximation of this equation when x is close to 0. And that is that one. Okay, so why don't you try C on your own and see if you can come up with the right answer. And I'm going to give you a hint. Before you try C, make sure you rewrite it as a what? You want to rewrite this as a power function. Okay, that means you want to rewrite it to the power of a half. Okay, so rewrite that and then find the linear approximation and write it in there. I'm going to do D with you because D looks a lot scarier. Would you agree? So D, again, I'm going to write it as a power function. So I would have 1 minus 1 over 1 plus x to the power of, this one, your root is 3, so that's to the power 2/3. Then I'm going to obviously see if my formula is going to apply. Here's the formula. 1 plus x to the k power. It's approximately the same as 1 plus k times x for linear approximation near 0. So let's identify what k is. K is this power. So k is definitely 2/3. X is this whole chunk right here, okay? So x is negative 1 over 1 plus x. All right, now let's plug it in. Linear approximation, 1 plus k is 2 over 3 times negative 1 over 1 plus x. Okay, let's try to simplify this, make it into a line. All right, so from here, we'll simplify that all together. Technically, that's a slope. Okay, so let's see. Distribute. Is that okay? So 1 minus 2 over 3 times the quantity of 1 plus x. Then if you want to, you can find a common denominator. Okay, so your common denominator would be 3 times 1 plus x to top and bottom. Then this will lead me to, minus. Okay. So that means on the top I would have minus 2. Then that will lead me to believe that's 3 plus 3x minus 2 all over 3 times 1 plus x. Then that will lead me to believe that I would have 3x plus 1 all over 3x plus 3. So this is the final approximation, okay, for your function f near 0. So that's the final answer. And don't forget to go back and do do C. If when I see you in class and that's not attempted or done, then I cannot give you a credit stamp. And this is the end of our notes today.